Hello and welcome back to this amazing channel. This is Abhinav. In this particular video, we will discuss about the contest Starters 124. So we will discuss about the first four problems of this particular contest, which is of division 2 basically. Binary, parity, table strength, swap and unite, and make it one. These are the four problems that we will discuss in this particular video. Let's start with the first problem. So the very first problem is binary parity. This was a really easy problem. The problem says that you are given with a number n. You have to first of all find the sum of binary digits of the number. Basically, so for example, if the number is n, and if let's say n is 23. So first of all, you have to convert the number 23 into its binary form. Or in the other sense, you have to find the sum of binary digits in the number n. How you can find the sum? So what you can do, you can continuously divide 23 by 2, and whatever is the remainder you can store in some sum. For example, here remainder will be 1, then it will be 11, then again remainder will be 1, then it will be 5, again remainder will be 1, then it will be 2, remainder is 0, and then 1. So overall it's this will be the uh, so basically this will be the binary form of this number n, right? And if you will find the sum of this, it will be 4. 1 plus 0 plus 1 plus 1 plus 1 is 4. Now, based on this number 4, basically based on the sum of these binary digits, if this is even, you have to print even. If this is value is odd, you have to print odd. This was a really easy problem. If you will see, what I have done is, I have simply taken an input of number n. Now I am dividing that n by 2, and each time I am storing its bit in a number c. So n mod 2 is stored in a c. For example, initially n mod 2 is 1. So 1 plus this 1, then plus 1, then plus 0, then plus 1. Okay, basically we are counting every binary digit, and if at the last, if this sum is even, we are printing even. If this sum is odd, else we are printing odd. So a very straightforward question it is, right? I hope that you have got this particular problem. Now let's discuss about the next problem, which is table strength. This was again a easy problem. So in this problem, table strength, what they were asking was that basically they were saying that there is a table, okay, and table has some legs. So basically, like mostly we can say that table has 4 legs. For example, this is a table. It mostly has 4 legs, right? I have a very good drawing, but they are saying that there are n legs in the table, right? There are n legs in the table, and there is some weight w that is placed on the table. There is some weight w that is placed on the table, right? Now what you can do, like what happens, that this w weight is equally distributed amongst all the legs of the table, right? Now what do you have to find? So you have basically n legs, right? For example, legs are 2, 1, 8, 6, 2, 4. Let's say this is there's a table which has 6 legs, and these are those 6 legs given to you in the form of an array. Basically the strength of that 6 leg. Strength means they are giving wi is the strength. Strength means how much weight a leg can bear. For example, leg number 0 can bear weight of 2 kg. Leg number 1 can bear weight of 1 kg, and so on, right? Now let's say overall weight is also given to you, I guess. Okay, that is basically you have to find. So for example, overall weight is 20. So if overall we have 20 weight, right, and there are 6 legs, so each leg will have something around 3.334. Each leg will have something around this. Okay, but what we can do, they are asking us that we can select some non-empty subset of these legs. Means we can select, there's no need to take all these n legs. We can select some specific legs from this, some subset of it. Let's say, for example, I opt for. So if you will see currently, if you will see all the 6 legs, if you will see, if you will take all the 6 legs, each leg will bear a weight of 3.334. And can they afford it? No. If you will see, these legs cannot bear a weight of 3.334. They will break. So means we cannot take all the legs if we have weight 20. Okay. Now let's say if I will just take these 3, then what will happen? If there are only 3 legs, then 20 by 3 will become something around 6. then so it's like 6 3 18. Okay, again it's something same 6.6 something, right? So now what will happen is, now each, if we are just taking these three legs, each will bear a weight of 6.667. Again, there's a problem because these both cannot afford 6.667. They have this max of 2 and 6. Now let's say I took these three legs. For example, I have taken legs, some other legs basically. So now what do you have to find? You have to basically find that which subset of leg you should choose so that you can afford maximum weight. Maximum weight. Let me give you example. For example, if you opt for legs, this one, and this one. For example, you choose leg 2, 8, and 4. If you have chosen leg 2, 8, and 4, that means the maximum weight that they can afford is 2 only. They can only afford a weight of 2. Why? Because this can only, so because weight is equally distributed among legs. Weight is equally distributed among legs. So they all will bear same weight. Let's say x. And what can be the value of x? X cannot be more than 2 because there's a leg which can have 2 only, which is the minimum value among all the legs. So x can become max 2 only. So if x can become 2, each leg can bear 2 amount of weight, and there are 3 legs. Total weight that they can get is 6. But is this the maximum that we can get? No, this is not the maximum. Let me tell you what the maximum is. Maximum will be if we will take 8, 6, and 4. See, if you will take 8, 6, and 4, then what will happen? Then each leg can bear a force of 4 equal, not more than 4. If you will take 5, this cannot afford, right? Now each can afford 4, and there are 3 legs. So total weight can be 12. There is actually one more option, which is 8,6. But in 8,6 also it will give 12 only because each will take 6 and 6, and 6 into 2 is 12. Right? If let's say here it's 7, in that case in 8,7 it will get 7 and 7, and 2 will be 14. So there will be multiple cases where we can have multiple weights if we choose some specific set of legs. So now let's discuss how we will choose these legs. So guys, what we will do, see basically. So the leg which has the lowest capacity, it can have lowest, right? And for example, if we are choosing some set of legs, for example, we are choosing 1, 7, 2, 4. If you will see, the smallest among this is 1. So if this is 1, means all of them has to suffer 1 only. They cannot have more than 1 because all of them have equal weight. And total weight will be 1 into 4, which is 4 only. So guys, for each leg, we will see that if we will consider a leg and we will consider all the legs more than its strength, then what is the weight they can have? So what we will do is, we will first of all sort the leg. We will first of all sort this array. So after sorting, it will become 1, 2, 2, 4, 7, 8. Right? Amazing. अब देखो हम क्या करेंगे. Now we will first assume. Now let's say it's 0, 1, 2, 3, 4, 5. Now see what we will do. We will first of all assume that I have taken this leg. I have taken this and all which are greater than it. I have taken all of them. So if you will take all of them, total legs that you have taken is 6 total. And what is the maximum weight that each can have? It is 1 only. You cannot not have more than 1 because 1 is the minimum value. So total you can get is 6 only. Now let's say you are not considering this. You are considering this and all of these. So it will be 2 into 5, which is 10. Now let's say you are just considering this. It will be 2 into 4, which is 8. Then let's say this. It will be 4 into 3, which is 12. Then let's say this. It is 7 into 2, which is 14. And then only this, which is 8 into 1, which is 6, which is 8 only. So the maximum of all these weight is 14, and 14 is the answer. That is what we will do. कि हम एक एक लेग को देखेंगे कि अगर if we will take this minimum leg, अगर हम इस वाले लेग को लें और इससे बड़े सारे लेग्स को ले लें, तो वो वाले लेग का मिनिमम आपका होगा सब में डिस्ट्रीब्यूट और इनटू कर लो टोटल कितने लेग्स हैं, राइट? So if you will see what I've done here, I first sorted the vector. Now what I'm doing is, after sorting, I'm considering the current leg where we are. I'm considering the current leg where, which is Vi. Because Vi is the minimum one, that weight will be distributed among all the greater legs also. And then we are multiplying it with how many number of legs are there. For example, when we were there, For example, when we were there at 2, so we are multiplying 2 with what? With all the legs till end, means which are greater than it. So how many those are? 4 are there. How you find that? You subtract basically n minus I. N is total number of legs and I is the current index where you are. So for first n minus I will be 6, then 5, then 4 and so on. Right. So I'm multiplying Vi with n minus I and I'm taking the maximum of all such values, right? So I will provide the link to this particular code in the description. You can check that out. And if you have any doubt, you can ask that to me. Amazing. Great. Now let's move forward to the next problem. Also, yeah, again, if you have any doubt, you can ask that to me in the comment section, or you can also you can join a telegram group to ask your doubts, right? Amazing. Let's move forward. This is the next problem, which is swap and unite. This problem is you have a string s and consisting of lowercase letters. So basically you have a string s and s consists of all the lowercase letters. What you have to basically do is that you can perform some swap operations in the string, and by performing swap operation you have to make at least one character unite. What is unite? Unite means all the occurrences of a particular character should be at one place. Should be at one place. Let me give you an example. For example, the let's say the case is A C C B A C A. For example, this is the case. So there are multiple. Let me change it with some other. Let's say D and A. Okay. So you can see that A is present 3 times here, B is present 1 time. Let's say two. Okay, let's 1 time. Now C is present 3 times and D is also present 1 time. So see, is there any character here? Is there any character present here which is unitely present? Yes. See, B is present only 1 time. If a character is present 1 time, means all of their occurrences united. No problem. The problem comes when it is not. For example, this is not there. It's simple. ACA. Now what you will do? Now let's say they are saying that you have 3 occurrence of A and 3 occurrence of C. But none of them are united. United means neither A are present in a contiguous manner, neither C and C are present. So we have to perform some swap operations such that they become continuous. Any one of that. तो आपको सारे नहीं करने. You don't have to make all of them continuous. Any one of that, right? Either A, either C, or any other character which is present. So how you will do it, guys? How we will do it? So what we will do basically, guys, that for each character we will check that if we will try to make that particular character contiguous, how much swap operations we need, and then among all the swap operations we will find the minimum value. That will be our approach, right? Amazing. For example, so this is actually a easy approach. I think here you have to just make one swap like this, and this will become like this. So only one is the answer, because after one swap you can see C and C becomes united. I'm searching for a good I'm searching for a good test case. Let me see if I can get a good test case. Yeah. So for example, this is also not a good one. Okay, wait, let me search for something. Let's say it's A, then B, then C, then A, B, B, A, C, B. Okay, this is I think a good test case. Now here if you will see, A is present 3 times, B is present 4 times, and C is present 2 times. Okay, but none of them are united. Neither all the 3 A's are united, neither all the 4 B's, and neither both the C's are united. Okay, let's have 3 C's also. Otherwise, simply answer is one swap. Okay. Otherwise, you can simply swap it once. Now, if you will see, what will be the minimum step? So guys, first of all, what we will do, there are 3 characters A, B and C. First, we will check for A. So for all the characters, we will first of all find their frequency. Now for each character, we will try that if they are present contiguous, how much minimum swaps are required if we have to make them continuous. For example, if we have to make this A, which is present 3 times, contiguous, how many swaps are required? How we will check this? See, very careful, please focus. Okay, see, what we will do is, for example, A is present 3 times. I will first take the first slot of size 3. And now in this first slot, we will see how many A's are already present. So in this first slot, there is only one A. Means 2 slots are not A. That means 2 operations are required if we have to make this slot complete A. So your answer will be 2. Now, same if you have to make A here, how many swaps are required? Again 2 swaps. So answer remains 2 only, right? Answer remains 2. Now here again you can see 2 swaps are required. Answer is still 2. Here again 2 swaps because there are 2 non-A elements. Okay, great. Here also 2 swaps, great. Here also 2 swaps, great. Here also 2, and here even 3 swaps. Here if you want A, you have to make 3 swaps. You have to take 3 A's from here to here to here. So minimum till now is 2 only. Now let's say next. So now let's check for B. So first this is the B. So if we want all the B's here, we want 3 swaps because there are 3 non-B elements. There are 3 non-B elements. We need 3 swaps, right? Okay, still answer is 2 because we need minimum, right? Here we just need 2. Okay. Here again we need 2. Here again 2. 2 swaps are required because 2B's are already present. Here 2. Here again 2. Here 3. So still for B also answer is 2 only. Now check for C. C is 3. So let's take a window of 3. So first 3. Here 2 swaps are required. Okay, 2 is already the answer. Again 2 swaps are required. 2 swaps. 3 swaps are required. None of them are 3. 3 times you have to swap. No. 3 swaps. 2 swaps. If you will see here 2 are C and only one element is non-C, means only one swap is required. Means now answer became 1. And now after checking for all A, B and C, finally we have our answer. So guys, that is what we are doing. But here there is a twist. The twist is that how we will get to know that in a particular window each character is present how many times. And for doing that, I have used the concept of prefix array. So I am taking a prefix array for the whole size of this string. Okay. And for all the 26 characters, I am storing their occurrences in a particular range. How? For example, let's say this is A, B, C, D up to Z I am taking. This is the prefix array. So for the 0 index, A will be 1 and else will become 0. Why? Because till here, only one A is present. Now till here, I am saying till here, okay. Till here, one B is present and one A is also present. Else are 0. Till here, 1A, 1B, 1C. Till here, 2A, 1B, 1C. Now 2A, 2B, 1C. Now 3B, 2A. See, 3B, 2A, 1C. Now 3A, 3B, 1C. Now 3A, 3B, 2C. Now 3A, 4B, you can see. And then 2C. And 3A, 4B, 3C. Finally, till the end, we have all 3A's, 4B's and 3C's. Now using this prefix array, if you want to find, so I hope you all know about how we find the prefix sum between a sub array from L to R. Similarly, let's say if you want to find that from L to R in this window, let's say how many C's are present. If you have to find, simply take C's at 6, which is 1, subtract it with C's at 2, which is 1. So 1 minus 1 will be 0, 0 because there is no C in this window. Let's say if you want to find number of B's. So for number of B, we will take number of B at 6, which is 3, minus number of B at 1 before it, which is 1. So it will be 2. Means in this range there are 2 B's, right? That is how we will find something similar how we find the sum of a sub array. This is called a prefix sum concept. If you don't know, please learn it, right? Amazing, really amazing. Now let's see how I have implemented it. It was actually a good concept, I guess. So what I have done here is, if you will see, first of all, I've taken a map. In that map, I'm storing the frequency of each character. Now I'm creating this prefix array of size n, the whole size of this string for each character, 26. It's a 2D array. Initially, I'm making all the values to 0. For the 0th position, I'm making s of 0a plus plus. Basically, 0th position, whatever is the index, it got increased. Now for the next, from 1 to n, for every character I'm checking. For example, if correct index I is equal to a particular character whose index is j, 0, 1, 2 up to 25, so you will increase its value, means you will add 1 in the previous. For example, अगर यहाँ पे C आया है तो previous C में एक ऐड कर दिया, यहाँ पे B आया है तो previous B में से एक ऐड कर दिया, right? We add from the previous value of that particular character. This is how we got the prefix array. Now for each character from A to Z, if that character map value is 0, means if that was not present, simply continue. We have to only check for characters which are present. For example, A, B and C. If it is not present, continue. If it is present, let's see how many times it is present. If it is present, let's say 5 times, or let's say here B was present 4 times. That means you have to take window of size 4, 4, 4. So first window will be this, right? Second window will be this. Third window will be this. Fourth will be this. Am I right? Sorry. Yeah. So, fourth window will be this, right? So we'll check for each and every window. This one, this one. So we'll start from 0. So your we are taking I and J actually, if you will see. So my I will start from 0 and J will be here. This will give you a window of size 4. Then this is the next window. This is the next window, right? So each time I and j both will increase. So next I will come here, j will come here. Initially they will start from, I will start from 0 and j will start from xs minus 1. Basically, if b is present 4 times, j will start from 3, 0 to 3, means 4 minus 1, right? And now for each window, they are checking that how many times that particular character is present there. How? We are first checking at j. For example, if you are taking I to j for b, so at j, b is present 1 time. And because I is 0, there is no need to subtract. If I is, let's say, here, then we have to subtract this value, which is for I minus 1. Okay, the basic prefix sum concept, right? And now we are also, so now we are seeing overall there are MP of CH. For example, there are 4 Bs, but in the window, let's say there are just 3 Bs. So how many swaps required? 1 swap required. That is our number of swaps required for that particular window. And then we will find the minimum of all of that. And then we'll get to the towards the next window. So this is what we are doing. A typical concept, a complex concept I can understand. I hope that you have got this particular code. If still you have any doubt, any problem, you can no matter ask that to me in the comment section. You can ask that, or you can also join the Telegram where we share all, we do post contest discussions also, right? Amazing. So now let's discuss the fourth problem, which is make it 1. This was also a really interesting problem actually, because of one mistake, one wrong observation. I also did one wrong submission and I was able to solve this problem in the second attempt, right? uh, Contest is also ended. Let me see what's my rating change. Okay, so luckily I again became 5 star today. It is just touched 2004. I was like this actually became because I made a one wrong submission. If I made not that, it must be a good rating, but okay, no matter, I became 5 star. Cool. Yeah, so this fourth problem let's discuss, which is make it 1. So guys, in this particular problem, what we are doing is that we have a array from L to R, right? So we have uh, a array which has elements from L to R. For example, the elements are, let's say L is 7 and R is 15, or let's say 12. Okay, so the array will be 7, 8, 9, 10, 11, and the size of the array will be 6, which is actually L minus R plus 1. Oh, sorry, R minus L plus 1. R minus L, right? Now, what they are asking is, they are asking, this is the array A given to you. Now, you have to create an array B. You have to create an array B. This is array A. You have to create an array B such that GCD of element of A and B is always 1. GCD 1 basically means they should not have any common factor, because GCD is highest common factor or greatest common divisor. If they don't have any common factor, the common factor will be 1 only. That is the basic thing, right? So for example, if we have a number n, can we find a number which does not have any common factor or have a common factor of 1 only? Yes, guys. Actually, for a number n, it was a math and observation based thing. For a number n minus 1 and n plus 1 are the two numbers which will always has GCD 1. Which will always has GCD 1. For example, if your n is 10, if you will do GCD of 10 with 9, you will get 1. With 11, you will get 1. Why this happens, guys? So why this happens is, let me tell you the reason for it. For example, n is given to you. Let's say n is 20. Okay. Now, this n will have multiple factors. For example, 1 is the factor, 2 is the factor, then 4, then 5, then 10, then 20. So these are all the factors of this n. If you will take the value of n minus 1 and n plus, which is 19 and 20. 19 is a prime number, so it has just two factors, 1 and a number itself. 21 is having some factor. But you will see none of their factors will match. Why I am saying this? Instead of 1, none of their factor will match. And that is not just for 20, for any number you can check. The reason is, guys, the reason is, for example, if n is divisible by a number, let's say n is divisible by 2 or 4 or 5 or 6, that means n mod that number is 0. That means n mod that number is 0. Am I right? If n is divisible by 4 और 5, इसका मतलब क्या है कि n का उस नंबर से मॉड 0 है. तो अगर n का उस नंबर से मॉड 0 है, n प्लस 1 का उस नंबर से मॉड 1 होगा और n माइनस 1 का उस नंबर से मॉड, ये गारंटी है, कभी भी 0 नहीं हो सकता है. मीन्स इफ n is divisible by a number, n plus 1 and n minus 1 will never be divisible by that number. I'm not talking about 1. So x is not equal to 1. तो 1 के लिए हो सकता है. देखो 1 तीन सबका फैक्टर आ रहा है ऑब्वियसली. 1 हर नंबर से, बट बाकी किसी भी फैक्टर से ऐसा नहीं होगा. This was the observation. So if you have to map them, just map them on the basis of this value. कि अगर एक नंबर है, या तो उसको n plus 1 कर दो, n minus 1 कर दो. कि 7 या तो आप 6 से मैप कर दो, या तो आप 8 से मैप कर दो. Their GCD will always be 1. So what we will do? So guys, what we can do, we can simply do that for 7, we will map it with 8. For 8, we will map it with 7. For 9, it's 10. For 10, it's 9. 12, 11. So simply what we are doing is, we will, yeah, I'm back. So simply what I'm doing is, we are simply swapping the numbers. So every two number we are swapping. So it will become 8, 7, 10, 9, 12, 11. And because difference between all these numbers is 1, this will never give you GCD more than 1. This will always give you GCD equal to 1 only. And here's the reason. So in case when n is even, we can simply swap them. For every two pair, swap their values, and that will be the new array. It is very easy. But the problem comes when n is odd. So when, let's say, n is n, basically let's say L is 3 and R is for example 10. So in this case, if you will see, it is 3, 4, 5, 6, 7, 8, 9, 10. Okay, not 10, let's say 9 only. Let's say 9. Basically when both the parity are same. In this case, what will happen? N is 7. There are 7 numbers. Okay. So for the even numbers, we can do the same. Like for example, if this is A, we can make a B, for example, 4, 3. This then 6, 5, then 8, 7. For this 9, it will remain 9. which is a problem. Now what we will do for this 9, basically for this last number, this R, this is L, this is R. For this last R, what we will do, we will search in all this range that if we can swap this it with someone, and ultimately we'll get something. For example, we can swap it. For example, we can swap it with, can we swap it with this? No, we cannot swap. Because if you will swap this like this, oh sorry, yeah, like this, 9 and then 4. So here GCD will become 3. It's not good. Okay. Same, we can also not swap this. Because if 4 and if 9 and 3 can be there, it will also become GCD 3. Okay, we can also again not swap this, because again 6 and 9 will give you GCD 3. But we can swap this. You can see. Okay, we can even not swap this. Okay, we cannot swap this, because if 9 will come here, this will give you GCD 3. Okay, can we swap this? Yeah, we can actually swap this. So we can swap this with, now you can see all of them are giving GCD 1. Right? But if the case comes, so see, if n is even, then answer always exists. Answer always exists. Simply swap the pairs. If n is odd, in this case answer exists. Basically the case where both the values are odd. What I think. There is a case when it will not exist. For example, if let's say L is 16, R is 20. So it will be 16, 17, 18, 19, 20. It will be 17, 16, 19, 18. Now this 20 cannot be swapped with any of the number. Right? And in this case, answer will be minus. So how we are checking it? How we are checking it? See, what I'm doing it here, I am, okay, do we, yeah. Yeah, what I'm doing here is, just a minute. See, if n is even, in that case, I'm simply saying that swap the values, means in place of I plus 1, in place of I plus 1, I'm storing it in an array. You can directly print it also. But if the case when n is not even, when the n is odd, then for the first n minus 1 elements, I'm doing the same. For the first n minus 1 element, हम same चीज करेंगे. Now for the rth element, this rth element, for the rth element, I will again travels and I will see that with which index that rth can be swapped. If there is an index such that after swapping still GCD is coming 1, we will swap it and break. But if there is no such element, at the last we will check. At the last, for every index from 0 to n, we will check. अगर किसी भी एक इंडेक्स के लिए GCD -1 है, if for any index GCD is -1, that means it was not possible. For example, here, and we will print -1. In all the other cases, we will simply print our answer, which is our answer vector, right? So guys, this is how I am doing it. It was again a little bit, even it was again a complex but a observation based problem. So I hope that you have got it. If you have any doubt, please ask that to me in the comment section. You can also join Telegram channel, right, to ask your doubt. Thank you. If this particular video is helpful for you, please comment helpful and please like this particular video. Thank you. Thanks a lot.